So in this short video, we will have a look at how we can create a truth table with state transition diagram using a truth table. So I go back to my screen here. So we want to create a state transition diagram, and we are given this truth table. This truth table we have already seen how we can calculate using the circuit diagram in our previous video. If you haven't seen that video, you should see that video first and then come back and try to understand how we create a state transition diagram using this truth table. In some of the test exams or some of the interview scenarios, people can give you this truth table and ask you how to put it in a state transition diagram. Really straightforward mechanism, so I will try to explain it step by step here. So first of all, you start from somewhere. So this current state is 0, 0. So you draw the current state, and you see that from current state there are two possible transitions that can happen based on if input is 0 or input is 1. So here we represent input 0 with red color, input 1 with blue color. So you see when input is 0, red color represents that. So sometimes people will just simply write it here as an input and output. So instead of using colors, you can write 1 slash 0 0. 0 slash 0 0 for red, 0 slash 0 0, which actually means if your input is 0, your output is 0 0. Input is 0, your output is 0 0. And next state is shown by the destination of the arrow. So arrow comes back to 0 0, showing that you started in 0 0 state and you finished in 0 0 state. For the other transition, which is 1 slash 1 1. So here we are saying that input is 1, output is 1 1, input is 1, output is 1 1 here. And your next state is 0 1. So that's why you can see the arrow finishes at 0 1. So if we continue this for other states as well, so say for example next state is 0 1. So our starting point is 0 1. We can have two possible finishing points, 1 0 and 1 1. You can see 1 0 is one finishing point for this arrow, and 1 1 is another finishing point for this arrow. So input output relationship here is 1 slash 0 1, and input output relationship here is 1 slash 1 0. So this input output relationship is more convenient when you have one color. So for example, if you're doing it in exam and you have only single pen and you cannot use colors very carefully, then it's better to use input output. This input output notation also tells us the rate of the code. So one input always results in two outputs. So that's why the rate of the code is n is equal to 1 or n is equal to 2. Rate of the code is n is coded bits. There are two coded bits, and k is 1 because information bit is 1. So rate of the code is k over n, which is 1 over 2. This is important to understand that it should be correctly done. This is something that anyone can show you this diagram and can ask what's the rate of this code. So you look at the input over output. So 1 over 2, how many bits in the input and how many bits in the output. Okay. So looking at any one of them, I'm not translating 1 1 into 2 or 3 or whatever. Yes, I'm just saying 2 bit at the output and 1 bit at the input. That gives you the rate of the code. I hope that's clear. Thank you very much for your attention.